Right, so let's go through checkpoint 17. Driving power of 4000 watts is needed for a car of mass 900 kg to travel along a level road at a constant speed of 20 meters per second. So what is the driving force required to maintain the car at this speed? Meaning that the speed is also at 20 meters per second up a gradient in which the car rises 1 meter for every 12 meter of travel along the road. Okay, so let's take a look at the case where we are traveling at level road. So level road, right? So the power is about 4000 watts, and of course I travel at a constant speed of 20 meters per second. Means that the driving force, right, will be 200, because you simply just use 4000, you divide by 20. So since they say it's a constant speed, so I can safely assume that the frictional force, right, acting on the car is about 200 Newton or so. Because constant speed, right, acceleration equal to 0, resultant force equal to 0. Okay, so imagine that the same route, meaning that the frictional force is still 200 Newton, right, is being raised up to become something like a slope like that. So now what is our new driving force? So my new driving force, of course, must be greater, because not just I need to counteract the frictional force, I must also counteract the so-called the parallel component of my weight, right? Okay, so my frictional force will be 200 Newton in this direction. Okay, what about one more opposing force? Okay, the one more opposing force will be due to the weight component. So because there's a weight, right? So the weight is about 900 multiplied by 9.81, which will give you 8829 Newton. Since we know Tuakaso, we know that the angle of incline is about 4.8 degree using the Tuakaso, the sign, right? Okay, with this, I need to resolve the weight component. So meaning, for example, there's a perpendicular component, then there's one more is your parallel component. So parallel component is right here. So always remember, right, our weight component must be the hypotenuse. So this 8829 Newton is the hypotenuse. Then I want the so-called this parallel component, the black color arrow, right? So this black color arrow will be your opposite. And of course, don't forget, there's one angle right here. This angle is 4.8 degree. Always remember, the angle between the purple arrow and the hypotenuse will always be the 4.8 degree. So with this, I simply just calculate what is my black color arrow, right? So the so-called the parallel component to the slope. So 8829 sine 4.8 degree. So this will actually give you some sine 4.8. So it's about 739 like that. 739 Newton. So this thing, right, 739 Newton. So since I want to travel up at the same speed of 20 meters per second, so my engine force must be equal to 200 plus 739. So it's about 939. So the engine force is 939 Newton. So they actually ask us for the driving force, right? So we simply just round it off for them to be 940 Newton. So the answer for this will be B.